In this video, we want to show you how DEA Deutsche Erdöl AG uses modern 3D seismic technology to find oil and natural gas resources that may be located several kilometers below the surface, in the Egyptian desert, under the open sea off the coast of Norway, and also in the development of new oil and gas resources in the lowlands of northern Germany. To understand the geological structures below the Earth's surface, we need to go back several 100 million years and look at how petroleum and natural gas were created originally. The starting material for the formation of natural gas and petroleum are the remains of organic substances from living organisms, usually plants, that lived in the water or on land in the course of Earth's history. Covered by layers of sand and clay, microorganisms in the fermentation layer begin to break down the dead material. The remains of the organisms are converted into hydrocarbons in the process. Over time, this layer of fermenting mud is covered by additional layers of sedimentation. As the pressure exerted by these sediment layers builds up, natural gas and petroleum are eventually forced out of the bedrock and migrate towards the surface until they encounter an impermeable rock formation. In this way, hydrocarbons accumulate in the so-called reservoir rock, from where we extract it today. Today, the search for fossil raw materials from the Earth's surface is mostly carried out using modern 3D seismic technology. In a process similar to that used in depth sounders on board ships, sound waves are generated near the surface, and the sound waves reflected back from underground are then recorded. The sound is often generated with a so-called vibro truck, which generates the sound waves through a vibrating baseplate. The sound waves bounce off the various boundaries between different rock formations underground. Geophones on the Earth's surface record the reflected sounds. The time it takes the sound waves to return to the surface provides information about the composition and location of the rock formations. Depending on conditions on the surface, small explosive charges set off in shallow boreholes can be used to generate sound waves, as an alternative to the vibro truck. Seismic surveys carried out at sea work in a similar fashion. Here, air pulses are placed in the water from a seismic vessel. Sound waves generated by pressurized air penetrate the ocean floor and are reflected by the boundaries between different geological formations. The reflected sound signals are recorded by hydrophones placed in the water. State-of-the-art high-performance computers are used to generate a detailed seismic image based on millions of units of recorded data. Using complex calculations and simulations, this information is then combined with other geological data, from existing wells, for example, or from aerial photographs. In this way, we end with a complete three-dimensional picture of the underground structures with all the different sediment layers. With the help of these findings, we can then decide the most appropriate locations for drilling wells. Modern 3D seismic technology makes a major contribution in our efforts to minimize interventions in the natural environment, at the same time as we endeavor to secure the energy supply of the future.